Alright guys, I just want to do a quick thing on balancing, just so you guys have some extra practice and just kind of see how it's done in case you need some more help. With balancing, remember what we're doing is we're looking at all the subscripts and elements that are on each side of the arrow. Kind of think of your arrow like an equal sign, if you will. And what you're trying to do is get both sides to equal each other. So what that means, over here we have one zinc, and the reason we know there's one zinc is there's no subscripts after it and there's nothing else insinuating that there's a number. So there's one zinc here, and then on this side we also have one zinc, because again, no number after it. So our zincs are equal to each other on both sides of the arrow, so they're balanced. Looking at our leads, again, Pb only 1, Pb only 1. So our leads are also balanced. Then looking at our nitrates, when you have a polyatomic ion that's on both sides of the arrow, treat it as an element. Don't try to treat it as nitrogen and oxygen. Treat it literally as nitrate. So remember, if you have parentheses around something with a number outside of it, that tells you how many things there are inside of the parentheses. So in other words, NO3 parentheses 2 tells us there's 2 NO3s, or 2 nitrates. So we have 2 nitrates on this side, and we also have 2 nitrates on this side, because again, we have the parentheses with the 2 on the outside. So this guy is already balanced. We don't have to worry about it. Now, looking at the next one. Okay, over here we have 1 aluminum, 1 aluminum. Our aluminums are good, but check out our bromines. Here we have 3 bromines, here we have 2 bromines. That's not okay. We've got to fix that. But I can't go in here and change my subscripts. The subscripts are set due to the compounds in which they're making. So instead what I have to do is, okay, 2 and 3 go into what number? Well, they both go into 6. Okay, well, what times 3 gives me 6? Well, I can put a 2 out here. And remember, the number, the coefficient, has to go in front of the compound. It can't go in the middle or anything. It has to go on all the way at the end. And that then means this 2 goes to everything, including the aluminum, in the compound. So that means we have 2 aluminums and we have 6, because it goes down to this 3, 6 bromines, and it is a multiplication. So 6 bromines go over here. We have 2. Put a 3 on in front. That gives us 6 bromines. Okay, but let's go back and look at our aluminums. I now have 2 aluminums and I still only have 1 over here. So I'm going to put a 2 out in front, and again that gives me 2 aluminums, because again it goes to everything in the compound. It also means it goes to this chlorine. So instead of having 3 chlorines, I actually have 6 chlorines. Well, I only have 2 over here. Well, 2 times 3 gives me 6. So now I have 6 chlorines. So just double checking. 2 aluminums, 6 bromines, 6 bromines, 6 chlorines, 6 chlorines. This guy is now balanced. Okay, coming down here, we have 3 sodiums and 1 sodium, so I'm going to start by putting a 3 out here. Okay, well that 3 gives me 3 chlorines. Well, I have 2 chlorines over here, so this is where we might have to play a little bit with these to try to get them to work properly. Problem is if I change this to a 2, I don't have the right amount of sodiums. Because I'm looking at something with a factor of both 2 and 3, just like last time up here where we had to look at what both 2 and 3 go into, I need to make it go into 6. So instead of having a 3 here, I'm going to have a 6 here. Okay, and let me put the plus sign back in real quick. Alright, so we're going to put a 6 here, and that 6 is going to go to sodium and chlorine. Now I can work with this a little bit better. Because I have 3 sodiums here, I'm going to put a 2 here to make it 6. That also gives me 2 phosphates. It might help to put the polyatomic ion in parentheses so we see it completely. So 2 phosphates. I already have 2 phosphates over here, so that's good to go. I have 6 chlorines from over here, so I'm going to put a 3 here to give me my 6 chlorines. That also gives me 3 calciums, and I already have 3 calciums here. This guy's already balanced, and you had one on your quiz like this the other day, so something very similar to that at least. Alright, so that guy's balanced. Let's look at the last one on this page. Our potassiums are already balanced, so we're going to leave them alone. What we're going to do is look at our chlorines. We have 2 here and 1 here, so we'll put a 2 out in front. That gives us 2 chlorines and 2 potassiums, so we'll put a 2 up here to give that potassium. Sometimes they're easier than others. That one's a real easy one. Okay, let's look at the other 4 we did. Okay, on this one, we have one aluminum, so our aluminums are good to go. Here we have one hydrogen and two hydrogens. Here's where the hydrogens are not good, but just kind of a trick that you get used to seeing. Notice that this chlorine is 3 and this hydrogen is 2, and I have to get both of these to equal 2 and 3 separately. This again is that case where we have to go, okay, I'm not actually going to go to 2 or 3, I'm going to go to 6 again, because that's what 2 and 3 both go into. So instead of having 2 hydrogens, I have 6 hydrogens. So I'm going to put a 3 on in front to give me 6 hydrogens here. So 6 hydrogens, 6 hydrogens. 6 chlorines, 3 times 2 gives me 6 chlorines. So now I have 6 chlorines. I also have 2 aluminums, so I'll put a 2 out in front here. And now that guy's balanced. 2, 6, 2, 3 would be our coefficients. Okay, next one we see a little bit of a problem. Notice our polyatomic ions, and I'll put phosphate over here in parentheses as well. We have hydroxide on this side, but we do not have hydroxide on this side of the equation. That means we cannot treat this as hydroxide. We're going to have to treat it as oxygen and hydrogen separately. Now phosphate's on both sides of the arrow, so we're going to treat that as phosphate. We're not going to break that up into phosphorus and oxygen. So keep in mind that this oxygen and phosphate is not going to affect our oxygens that we're balancing in hydroxide in water. They are treated separately. They're not oxygens at all. They're a part of phosphate. So let's look at how we would do this. I have calcium over here, and I have 3 calciums over here. So I'm going to put a 3 on in front to give me 3 calciums. But that also gives me 6 hydrogens and 6 oxygens. Remember, this 2 goes to everything inside the parentheses. So we already have 2 oxygens and 2 hydrogens to begin with. We're multiplying that by 3, so we get 6 oxygens and 6 hydrogens. Just another quick note. Notice there's 2 sources of hydrogen on this side of the equation and only 1 over here. Since that's the case, I'm going to leave hydrogen alone, and I'm not going to balance that guy until the very, very end. I don't want to mess with him just yet. So let's look at our oxygens. We have 6 oxygens over here, and remember, I'm not looking at this oxygen in phosphate. I'm ignoring that oxygen because I'll balance that oxygen with the other phosphate momentarily. So over here we have 6 oxygens, over here we only have 1. So I'm going to multiply this guy by 6 to give me 6 oxygens. And again, I'm ignoring hydrogen for right now. I'll fight with the hydrogens in a little bit because they're going to be the most difficult because they're split. And then the last thing we have to look at are the phosphates. So over here we have 2 phosphates, over here 1. So I'm going to put a 2 out in front to give me my 2 phosphates. So far, we've got 3 calciums, 6 oxygens, 2 phosphates, 2 phosphates. So the last thing we need to look at is our hydrogens. Over here, we've got 6 times 2, 12 hydrogens. Means we have to get 12 hydrogens over here, but remember they're split, so we have to add them. 3 times 2 gives us 6 hydrogens here. 2 times 3 gives us 6 hydrogens here. Well, 6 plus 6 gives us 12 hydrogens. So the hydrogens are actually already balanced. That's the nice thing. A lot of times when we have elements split like this and we save them for last, 9 times out of 10, they'll work themselves out. So that's why it's easier just to leave them alone, and then they'll probably be fine by the time you're done with the equation. So this one's balanced. Okay, next one. We have our sulfate, so go ahead and put him in parentheses if it helps you see it. Let's go through and look at this one. And be careful here, this one's actually a little bit harder, and you know what? This one we're going to leave alone because I'm not sure it's balanceable from what I'm looking at. It might be a complex redox reaction. So we'll come back and look at this one maybe a little bit later. So let's check at this one down here. It got erased, so let's fix that real quick. We have hydrogen gas reacting with nitrogen monoxide, producing water and nitrogen gas. So let's go through and see if we can balance this guy. This one's going to be a little interesting, but not too bad. We have 2 hydrogens, 2 hydrogens. 1 nitrogen, 2 nitrogens. So we need to put a 2 out in here to give us our 2 nitrogens. But notice that gives us 2 oxygens. Okay, well then we come over here, put a 2 in front of our water to give us 2 oxygens, but that gives us 4 hydrogens. So then we put a 2 out here, 4 hydrogens. Actually, not too bad. Alright, so that's that one. We'll ignore number 7 for balancing right now, but hopefully looking at the rest of these just kind of helped review how to balance. Alright guys, thank you.